live. I just put that in the title that way. Sometimes in this, if you subscribe to me, sometimes if you are working on your own and you're like, oh, Mr. Dwyer's live with someone in honors pre-calc, I'm going to go watch and listen in. That's the other thing that can happen, is you can like listen in when I'm helping other people. So everyone gets the benefit from it. And you can watch it again later on my YouTube channel if you need to. Okay, so let's just get after it. So find the domain of each of the following functions. So for a function like this, the domain is always, notice that that's just a parabola, right? Opening up. So the domain of this is just going to be all real numbers, because the domain just means what you're allowed to plug in for X. That's what you can think of when you think of domain. What am I allowed to plug in for X? So this would be all real numbers, which is written like this in interval notation. Okay?
Okay.
The next one is a rational function. And when you have a rational function, when you have a fraction, when you have a fraction that has variables in the top and the bottom, the no-no or the taboo is you can't divide by 0. So the domain for this is going to be anything except for whatever makes the denominator 0. So what I like to do is I just literally write out x squared minus 4 can't equal 0. And I just know, all right, let's solve that equation. And whatever I get, that's what I can't plug in. So how do I solve this equation? Well, there's a couple ways. The easiest way is just to add 4 to both sides and take the square root of both sides. But don't forget, when you take the square root, there's actually a plus or a minus that work, right? Plus or minus 2. You good with that?
Yeah.
So that's the domain. So how do I write that? Well, I start by writing negative infinity, and then I go to the first number I'm going to come to of those two, -2 and +2, which is -2, and then union from -2 to 0. I'm sorry, from -2 to +2, union from 2 to infinity. That's how you write it in interval notation. So literally what that looks like on a graph, if here's my -2 and here's my +2, what that would look like is it would be this that way. It would be from -2 to +2, but not including them, and then to the right. So that's the way you can write it graphically, is you just put the holes there on it. Or another way you could write it is you could say all real numbers except plus or minus 2. Depends on how your teacher wants you to say it, but normally I think in your school they want you to say it like this in interval notation. Okay?
Okay.
This last one, classic square root function. Well, what are you not allowed to do? What's the taboo in square roots? What are you not allowed to take the square root of?
A negative number.
A negative number. So you want, this is slightly different. What I'm going to write here is I'm going to say that 4 minus 3x has to be greater than or equal to 0. Okay? Because whatever's inside here has to be positive, or non-negative, I should say. It can be 0. So now just solve this equation. So -3x has to be greater than or equal to -4. Divide both sides by negative. Hey, when I divide a inequality by negative, what do I have to do?
Flip the sign.
Very good. Flip the sign. So this becomes +4/3. So my answer is x has to be less than or equal to -4/3. So in interval notation, that means it's from -infinity to 4/3, including it, which means I put a bracket like this, which means it's included. Good?
Yeah.
All right, stop me if you don't understand something, otherwise I'll assume you do and we'll just keep going. It says use your TI and consider this function to answer the following, find the domain and the range. So now they want you to use your graphing calculator. So tell me what this is. I'll use my graphing calculator here. What is the what's the first term?
X to the 5th.
X to the 5th. Oh, actually I can see it here. I'm just looking at the stream since I'm streaming it. X to the 5th. So X to the 5th. And then whoops, I'm not streaming it anymore because I just changed. So you keep telling me. Sorry. X to the 5th.
Plus 3.5 x to the 4th.
Okay.
minus 2.5x to the third
Mm-hmm.
minus 12.5x squared
Mm.
plus 1.5x.
Hold on, I'm making a mess of this. Delete. Okay, this was x squared, then what? Plus what?
Plus 1.5x.
Okay.
Plus 9.
All right, so when I graph this, now I've got a little bit better app than you have because I'm on my iPad. So this is similar to what you have, but you're gonna do it a little bit differently. But what they're gonna be asking us for is, what's the first thing they ask us for?
Domain.
All right, so the domain, you can tell, right? What's the domain gonna be?
1 sec. I need to type into mine too. I can't see the graph on your screen at the moment.
Oh, am I not?
Yeah, I just see like the empty screen where it's like all the y equals. Oh, there we go. Awesome.
I don't know why. That was weird. So you
Yeah.
can see my screen and you can tell, right? What are you allowed to plug in for X? Is there anything, or I should say, is there anything you're not allowed to plug in for X?
No, it doesn't look like there are any limitations.
Yeah, there's no limitations, because really the only time you have limitations are when you're dividing by something. When you're dividing by a variable, you can't let that bottom be 0. Or when you're taking the square root or the 4th root or the 6th root, any even root of something, you can't take an even root of a negative number in the real number system. So those are really the only 2 things you have to worry about. So the domain here is all real numbers. Okay. Now it's asking what's the range, and the range also, you can tell, I didn't even need to use a graphing calculator. I could have told, but I wanted to do it so you could see. What's the range of this?
All real numbers.
Yeah, it's all real numbers. So the way I like to think of this is do a scan. I like to think of it as doing a, let me upload this video into the Jamboard so you can see, or this picture into the Jamboard. Let's see if I can do that. Image. Well, that didn't work. Image library. There we go. So if I take a look at this, what I like to do for the domain and range, I'll just make this big so you can see, is I call it a scan. I like to scan my graph. So if I'm for the domain, I'm asking myself, what X values have a Y value associated with it? So I start on the left and I just start scanning and I ask myself, is this line gonna eventually touch the graph? And will it?
Yeah.
Well, yes, it will. How about this line? How about this line? How about this line? Am I ever going to draw a line that won't touch the graph?
No.
I'm never. So the domain is all real numbers. And for the range, I do the same thing, but I start on the bottom and I do horizontal lines. Is this line going to touch the graph somewhere?
Yeah.
Yep, yep, yep. Am I ever going to say, nope, it doesn't touch? Am I ever going to say it doesn't touch?
No.
Never. So the domain and range are all real numbers. Okay.
Okay.
Now it says, now this is the part where you actually needed your graphing calculator. It says list the coordinates of any local and global max and min. So a local max or min, I'm going to draw it up for you on this graph. A local min would be here and here. Those would be local mins. Global mins means on the entire graph, is there ever a point that is the lowest point on the graph? Can I name the lowest point on this graph?
No.
And I can't. So there are none. For a maximum, for the maximums, the local maximums, I'll do in blue, are going to be here and here, because those points are the, if I draw an open interval around those points, those points, each of those points respectively, will be the highest point on that interval. That's the definition of local mins and local maxes. But there is no global max because the line goes up forever and I never touch it, right?
Yeah.
So that's how that works. All right. Questions about any of that?
No, I don't have any questions.
Okay. So let's find out how we actually find those points. So on your graphing calculator, you have a function slightly different. I like this because I literally just have to tap it and it will show me the max if I tap it right there. And if I tap it here, it'll show me the max. Oh, that's the y-intercept. That's not necessarily the max. So, oh, there it is. There's the max. See how it says max next to it? And if I tap it here, it'll say min. If I tap it here, it'll say min.
Mm-hmm.
And if I tap it here, it'll say intercept or 0. If I tap it here, it'll say 0, 0, 0. Those are my zeros or my x-intercepts. So this is a really good app. Your calculator is a little bit different. You have to actually go calculate. You have to click calc, and then you have to click max, and then you have to draw a left bound and a right bound. And make sure that they're left and right of the places. So what you have to do is, do you know how to do this? Do I need to explain it, or are you good?
Can you explain it?
Yeah. So I'm going to zoom in on this so you can see it a little bit better. So if you want to find the max, right? If you want to find the min, for example, right here,
Mm-hmm.
and I was doing in yellow. If you want to find that min, what you need to do is on your calculator, hit calc,
Mm-hmm.
and then hit min. And then the first thing it's going to prompt you for is a left. What's it say? Like left or something?
Yeah, left bound.
Left bound. So you need to put something left of that, but not too far left of it. So let's call it -2. You don't want to put it way over here. You want to put it here. Okay. In other words,
Yeah.
you're creating that open interval. And then it'll say right bound. So you want to put a right bound in here. So let's call it -1/2. Or sorry, -1/2.
Mm-hmm.
Got it?
Yeah.
And then it's going to say check or guess or something. What does it say?
It says guess.
Guess. It says guess. Now what it's telling you is, do you want me to guess the smallest point in that interval that you just gave me? And it's looking at it, the t-chart of values, and it's finding the smallest y value it can find on that interval. That's all their calculator is doing. It's literally calculating the minimum in that interval. So go ahead and hit enter, and it'll guess it for you. It'll think for a split second, and it'll tell you the point.
Mm-hmm.
Make sense?
Yeah.
That's how you do it.
Awesome. Thank you.
Yeah, no problem. All right, so next up, let's go to the next page, moving right along. On what intervals is f of x increasing and decreasing and constant? Well, you just found the mins and the maxes, right? So let's go back to this graph and let's look at it. So it's increasing from here. I'm on the left. See how if I jump on the graph to the left and I just jump on it, imagine I'm a flea on the graph, on the function. Am I increasing or decreasing?
Increasing.
Good. And then at that point, what will I start to do?
Then it goes down and decreases.
Decrease. Then at this point, what am I doing?
Increasing.
Increasing. And then at this point, what am I doing? Decreasing. And then increasing to infinity. So my increasing and decreasing, once you find the points, which did you find the points yet or no?
Not all of them.
Okay. I can do it pretty quickly on my, since I'm kind of cheating for you here. So I'll just do one of them for you as an example. There's your max, and the max is at negative. It's a max at the y value shows you the max, but then the x value shows you where that's at. The x value is what you want for your interval. So it's -2.63. So I'm going to write negative. I'm going to write that's increasing from negative infinity. Whoops. From negative infinity to -2, what I say, 0.63.
Yeah.
Approximately. And then I'm going to go union, and I'm going to find the next max point, because I'm sorry, the next min point, because remember, now it's going to increase from there, right, all the way up to there, whatever that, if I can find that min again, that max again. That's the y-intercept. I want the max. There's the max. The max is at 0.059, and the min was at remember 0.059, okay?
Okay.
Negative 1.5. So this is from negative 1.50 to what?
0.059.
0.059. You got what I'm doing?
Mm-hmm.
And then it increases again from this min point to infinity, because it's increasing from there toward infinity. Does that make sense?
Yeah.
So that's 1.28 to infinity. Okay, now the good news is I don't have to go back to the graph to find the decreasing points, do I?
No, you don't.
Because I have all the maxes and mins. So from in this intersection, from here to here, it's decreasing, and from here to here, it's decreasing. So all I have to do is steal those points that I wrote down. From there to there, it's going to be decreasing. And also from there to there, it's going to be decreasing. And it's never constant. Constant means it's a horizontal line. It's never constant. Okay. Part D says restrict the domain to -3 to 2. So they want me to restrict the domain from here, from -3, which is one of my zeros, to 2, which is right here. No, not quite. Trying to find the exact point of 2. Can I drag this? I don't know if on mine if I can do this. See how I'm just below 2 right there?
Yeah.
All right, so they wanted me to go from -3, not including it, to 2, okay? So notice what that graph does from -3 to 2. So now they want us to find the range in any local or global max or mins. Well, now we can find local and global maxes and mins. Let me steal this graph here. Let's see if I can duplicate it and drag it. Whoops. I don't know how to do this yet. Okay. Oh, that's how I do it. Yay, I'm learning. Okay. So they want us to restrict it and then find any local mins or maxes. So what we're doing here, I'm going to zoom in so you can see it better. What we're going to do is take this graph right here, and we're looking only from, what was it, from -2 to, no, sorry, -3 to +2, right? And we're including +2, not including -3. So the local mins, just like we had before, we're going to have the same local mins and local maxes, right? Because all those points are inside this interval. But now the difference that we have is we aren't going to have a global. Global would be, so here's what a global is. If I put this point right here, I figure out what that point is, that's definitely the highest point on that interval. If I look at this part of the function right there, there's definitely a highest point right there, whatever that value is. So I literally can just plug 2 in, and that'll give me my global max. Does that make sense?
Yeah.
But I can't do that for this point over here for -3 because they said not to include it. So what I have to figure out is which one of these 2 values was smaller, which one of these 2 minimums was smaller on that interval. And was it smaller than, yeah, it would definitely be smaller than 0, right? Because that value is 0. So it definitely, one of these 2 is going to be a global minimum unless they're equal to each other. So let's find out which one that is. If I tap there, that min is -2.81. If I tap there, that's -1.98. So this is the global right there. So -2.81 would be your global. Got it?
Yeah.
I'm gonna zoom back out of here and erase that stuff. So the global min is -2.81. And if you want to say at x equals whatever that point was. What was that point there? That was 1.28. You know how I know it was 1.28? Because I already found those maxes and mins, right?
Oh, okay.
Now you might not have to do that, but they might, sometimes they ask for that. So I'll put that in there for you. The local min is going to be that other point, which was, I don't remember what it was, wait, did I put that at the right point or was it the other one?
It might have been the other one because on my
Yeah, I think it was. I
negative
think it was. Yeah, I think it was the other one. So it's at x equals, what was that min? 1.5, negative 1.5?
0.5.
Okay. And the maximum is going to be whatever I get when I plug 2 in. So it's at x equals 2. So the max is when you plug 2 into the equation. So basically take that equation and plug 2 in. I'll let you do that. And that's going to be the max. And the min, the local min, is going to be at 1.28, at x equals 1.28, right? So whatever that value was that I looked at before, I don't remember what that was. But again, you can use your calculator to find that using that min max thing that I just talked about. And then the local, I'm sorry, let's see, yeah, that's right. The local max is going to be these points, right? The points that we had talked about before. That point right there and that point right there. Those would be local maxes. So use your graphing calculator to determine what those points are. You good?
Yeah.
Do we still have some time? Yeah.
Yeah, we have like 5 minutes.
No, we still have time. Do you want me to do that or do you want me to go on to the next page?
Can we go on to the next page or let me actually see what I have next? Because some of these like I know, but I just want to kind of go over.
I know you probably want to get to the piecewise function, so I just want even odd. I'll show you even, odd, and neither. That's really easy with polynomial functions. This is going to be, this one, the first one is going to be neither. You can tell right away by the exponents because there's an even and an odd exponent. It's going to be neither. And this second one is going to be even. And because there's only even exponents and it's okay that you have a constant term. Let me give you another example. X cubed minus 3x, well, let me even write 4x. The coefficients don't have any bearing on even and odd. It's only the exponents when you're doing this. So this would be an odd function. Okay, but this x cubed minus 4x plus 1 would be neither, because you can't have a constant function when you're doing polynomial functions and looking for odd. It doesn't affect it for even, it does affect it for odd.
Oh, okay.
Makes sense. So if you had x to the 6th plus 3x to the 4th minus 2x squared plus 5, this would be even, because you only have even exponents and the constant doesn't have an impact on it. And the reason for that is because even functions, the definition is that f of x equals f of negative x. And odd functions, the definition is negative f of x equals f of negative x. So if you plug in negative x into here for all of these, is it going to change any of the signs? You plug in negative x into all of these, the fact that these are all even exponents, what's going to happen to all the negatives?
They're just going to like kind of go away because they're being,
they're going to become positive. That's right. Those are going to be unaffected, and you're not plugging it into here, so it's the same thing. So f of x equals f of negative x. But for these ones, when you plug it into an odd, what does the negative do to it? What is plugging a negative in? What does it do to the sign out front here?
It stays negative.
It changes it. Yeah, it changes the sign. So if I plug in negative x here, this becomes a positive, right? So this would be a negative, that would be a positive, but then this didn't change because I didn't plug it into here. So f
Oh,
of negative f of x doesn't equal f of negative x for this one, but it does for this one because I don't have a constant term in there.
mhm.
And that's how that works. Okay.
Yeah.
All right. Well, our time is up.